All right, it's time to get started. Welcome, first of all. Thank you for coming. I did not expect so many people here, so it's really nice to see this room so full. I'm here today to talk about the future of cloud-native application development with Radius. Yeah, there we go. Have you ever been in a situation in which you needed to deploy an application to production that had all these complicated moving parts, like you need to deal with storage, you need to deal with compute, where to run your web servers, etc. All these parts of your application, they need to talk to each other. You need to be accessible from the public internet. You need to make sure that that is done securely and compliant. You need to have a way to deal with secrets. And, well, it can be quite daunting. Well, in this talk, I will explain at some point in the future how Radius can help you do this. But first of all, let me please introduce myself quickly. My name is Loek Duys. I am CTO of the Microsoft Services service line of CPH, which is a consultancy company from the Netherlands. And, well, the good news is I'm also still a cloud architect, so I have actual hands-on experience doing stuff and not just book knowledge. So what you are about to see is a glimpse of the future, right? So that means two things, that I'm using pre-release software, and the downside of that is that stuff fails unexpectedly. So please be very forgiving in that aspect. And also that means that the stuff that I will show you today is not production ready yet. So I'm definitely not recommending to start using Radius today, but it is really useful knowledge to see what's coming, and then you'll be prepared about the theory behind Radius. Well, this is the agenda for today. I will be taking you step by step, small steps at each time, and show you an ever-increasing complex application. So we will start off very simple, with just a single front end, run that somewhere, and we will end up all the way in the cloud running a somewhat professional system. Well, I think it was Confucius who said, study the past if you want to predict the future. So let's see how we ended up with Radius in the first place. So about 20 years ago, when I started my career, we were building these cool monoliths. And that means that these were very simple applications. Everything was just packaged into one solution. But the downside of that was that if the application failed, then the entire system was down. And it made reuse of components a little bit harder. And this is when we started using services-oriented architecture. And that means that you chunk up your system and make it into reusable components. The downside here, of course, is that if a service always relies on another service, you haven't really gained anything, and you build a distributed monolith in which a single issue could still lead to total system failure. About at the same time, we were starting to do DevOps, and that means cultural change within your organization. And you now, all of a sudden, as a product team, are responsible to both build your application, but also deploy it into production and start monitoring it to see if it keeps running healthy. That means additional complexity within the product team. We also started doing microservices. In my mind, this is services-oriented architecture done right, if you do it right. And that means that, sorry, I'm just going to take this away a little bit. Yeah. Microservices means autonomous teams building autonomous services. And if you do it well, then, well, it gains you a lot of velocity and autonomy. But if you do it wrong, well, stuff keeps failing, of course. And, well, in order to know how to do it right, you need additional knowledge. For instance, about containerization. Microservices often run in containers. Sorry, last time. Yeah, still audible? Okay, cool. Yeah, it was disturbing me. Okay. Containers and containers orchestration. If you package up all your microservices in containers, then that means that you can package up your application together with its dependencies, like frameworks, DLLs, all that goodness, and run it on a container orchestrator to keep it running stably at scale. Unfortunately, it does mean that you need to know about containerization, how to make containers of your application, and how to run them at scale in production. Again, increased complexity. Well, you see where I'm going here. Cloud-native software that started about early 2020s. And that means software that was always intended to use cloud services. So it's up and running quickly by using all these cool PaaS services in the cloud, with the downside that you now need to know about which PaaS service to use when. Again, complexity. Where does it end? Well, hopefully it ends with platform engineering, in which you have at least a system, or preferably a team running a system, a platform team, making sure that they support product teams in their efforts into going into production. So you have a team that makes up the best practices, you have a team that has golden paths into production. And again, this decreases complexity for the product teams, but you will need to have a platform team who has all that expertise at hand. And an additional point here is that you need a platform. And of course, you already guessed it, this is where Radius will come in later, of course. All right, so if you remember that nice image I started off with, how do you get that into production? Well, this is generally the road to production, or the shopping list that I will take you through today. So we will one by one cross off these items, ending up with the system running in production. Cool. Radius is a platform engineering tool. So it enables product teams to become more efficient by offering golden paths into production. So the cool thing here is that it's not necessarily cloud specific, so it will run on AWS, it will run on Azure. In the future, it may even run on Google Cloud, and it can also run on your laptop, your Raspberry Pi, well, anything. It runs everywhere, and that's kind of convenient. It was originally built by Microsoft, by the incubations team there, but now it's been converted into a CNCF project, making it a publicly supported open source project, so you can either view the sources, or you can even make contributions there. Radius' intent is to reduce the cognitive load for product teams. So if you are building software, you don't want to be bothered with too much operational and infrastructure stuff. Radius can truly help you here. It does that by facilitating collaboration. So it has features for operations perspectives, it has features for development perspectives. And well, in essence, it is just a platform that will run containers for you. Additionally, it can also manage cloud resources for you. And don't worry, I will definitely zoom into every one of those parts. So let's first visit that collaboration bit. Radius is all about applications. An application is just a collection of moving parts. So an application can be defined, come to that later. It can be understood by developers, and it can be understood by operations. And they will each have their own roles to play in this story. It also has support for application lifecycle, so it can take you from test to production, etc. And it has team environments in which teams can be isolated or working together. It also offers application building blocks. So, for example, again, you can use it to run containers, but there's much more you can do with it, like state storage, PubSub messaging, networking, and all that sort of niceness. Radius itself runs on Kubernetes. That means that you need a Kubernetes cluster somewhere. This is where the operations bit comes in, of course. So you need that first. Then you can install Radius on it, and then it exposes APIs. If you talk to those APIs, you can make stuff run on that same Kubernetes cluster. So it runs on Kubernetes, but it also operates on Kubernetes. And you do that by using the CLI. So Radius comes with a CLI in which you can type commands. You will talk to that API running on Kubernetes and run stuff on Kubernetes using that CLI. And again, that may sound a little bit tricky. That is why I have lots of demos today. The way you do that, the way you run an application on Radius is by using a bicep template. And if you are a Microsoft-oriented software person or an architecture person, then you think, bicep, that was for Azure resources, wasn't it? Well, that's no longer the case. So nowadays, you can use bicep for Azure AD, you can use bicep for Radius, and you can use bicep for much more. For example, Kubernetes resources. So one language to rule them all. And the cool thing is you can also use bicep to create AWS resources nowadays. So let go of the bicep versus Azure link in your mind. All right, so let's check our roadmap here. So I think it's safe to say that, well, I repeated it a couple of times, you can use Radius to run containers, and now we know you run them on Kubernetes. So we can cross off the compute part of our shopping list or roadmap. But again, well, how do you do that? How do you get one of those applications to run on Radius? Well, you package your application as part of an environment. An environment is there to specify a specific life cycle stage. So every application usually has a test environment or non-production environment and a production environment, sometimes even more, like the whole DTAP thingy. If you want, you can build that using Radius environments. Please do realize that an environment is not a security boundary. This is where Radius resource groups come in. Again, if you are a Microsoft Stack user, then you think, oh, this is probably an Azure resource group. No, definitely not. Not the same thing. A Radius resource group is something else than an Azure resource group. In the future, a Radius resource group will be a security boundary. Right now, that is not been built yet. So again, pre-release software, so this feature is not in. It is a container for environments. So you can have a dev environment, a test environment, and an acceptance environment, all be part of different environments running the same application. And you can put all those environments in the same resource group, and then say, well, this product team has access to that resource group, thereby offering them access to each and every one of those environments. Right, okay. One more layer of complexity before I go into the demo, so bear with me here. I already mentioned that Radius runs on Kubernetes. Well, which cluster do you want to talk to? And this is where workspaces come in. So a workspace is something that lives on your development machine, much like the kubeconfig file if you are a Kubernetes user, and it targets a resource group on a specific cluster. So you select a workspace, you do that using the CLI, so the CLI knows where to find the API of Radius to talk to. And that means you can use the same CLI, different commands, against many environments by selecting the right workspace. And again, later on, when I demo more and more, this will start making more and more sense. So if you got this, more or less, then you should be fine for the coming 45 minutes. All right, so enough talk for now. It is time for the demo. And again, I did my utter best to make the demo really nice and always work, and therefore I scripted the whole bunch. But I didn't make a movie because I really like live demos. Well, your mileage may vary, but this is the first demo. Back to the slide. Very simple application. I will only deploy one container that has a web server in it. Can we do questions after, please? Yeah, great. One container that runs one web server in it and nothing else. The simplest demo possible. Okay. So this is my script runner. Can you read it all the way in the back? Cool. Well, go to the correct folder. and first start showing off my workspaces. So I do that by rad workspaces list. And you can see my machine has defined 2 workspaces, one cloud, one local. You can already guess where I'm going, right? So first I will target local. And then I need to create a resource group to deploy my application into later. Okay, I have made a resource group named test now. Let's see it. I can output it from the CLI as well, so I can see what's going on within that resource group. Well, it's not too interesting, but just to show you that this is very similar to the kube control CLI. Now let's deploy my first application. I need to indicate the bicep file I want to deploy. I need to indicate the group I want to deploy into. And I need to name my application, and I name it demo1. So this could take a little bit of time. So while that is running, I will show you the app v1 bicep file. Make it. Is this readable as well? Cool. All right. So a radius file always begins with the import of the radius extension. So that extension radius line on top of the file, that imports the radius types into bicep. So it knows the stuff that I'm using here. For example, a radius environment, a radius application that targets a specific environment, and a single container that targets the application and environment. So now you can see an application consists of multiple moving parts. In this case, I have only one. I'm running a single container, and I am running it at port 3000. Well, the deployment should have been finished right now, and that means that I have stuff running. And, well, may not be immediately obvious, but what happened with my rad run command was that the application was started, and also port forwards were created. So I can now talk to my Kubernetes cluster using commands fired at localhost. I have port forwards from port 3000 and 7007. We already know that 3000 is my app, but there's more. Let's first go into that 3000 app. Right. Well, this is a demo that is created by the Radius team themselves. The cool thing is that it shows very well what's going on within Radius. And I will show you this demo again later, and then it will be slightly different. It is just a simple web front end, and you can see stuff like the environment variables that it has. And you can see that, well, Kubernetes apparently injected some stuff into it. And it has an IP address that talks and listens to port 3000. And, well, that's about it. It's not a very interesting demo in that sense. But there was also that 7007 port. And this is the Radius dashboard. Like every good open source project, it has a dashboard. And this is the way you can talk to the Radius APIs using a friendly dashboard. So everything that you can do. No, that's not right. Some stuff that you can do with the CLI, you can also do with the dashboard. The dashboard is currently read-only, so this is why I corrected myself. So I can look at my dashboard to see the application that I'm running. Well, it doesn't add a lot of detail, but this is very similar JSON here. The JSON here is very similar to the bicep file I deployed earlier. One additional cool thing is this app graph thingy here. Again, for a very simple demo, it's not very useful, but you can imagine if your application is more complicated, then this could really help in understanding what's going on in your application by making it graphically visible. All right, I will terminate my application and then say delete the demo because I want to do it again later, but then slightly different. While this is running, switch back to the slides here and move on. All right, so if we take our roadmap to production and have another look at it, well, by using Radius environments, Radius resource groups, and workspaces, we can see we can have places for teams to work in isolations, and we can have places for teams to work in collaboration. But, okay, well, how do you start efficiently using one of those environments? And this is what we'll do next. So, for example, let's add a little bit of state to this story. So in this case, I will have a front end, and it will talk to an API, and the API will use a state store, because I want to persist some state in my application. So as a developer, I just say, well, I want to store a little bit of data. I don't really care where that data will reside or what actual implementation of the data store is, if it's cloud or if it's local. I don't really care. I just want to have a nice test environment. But if you look at it from an operations perspective, they will say, well, I don't care about the software. I just want the data to be compliant at all times. And I want to have security. And I want to have connectivity in place and so that I can monitor everything. So two different perspectives, and I will show you how Radius helps you with both of those perspectives. And this is where recipes come in. All right, so we've all been there. We need some way to, well, to define a little bit of infrastructure just because we want to store a little bit of data. And that can become a little bit tedious. So if, as a developer, again, I just want a data store, and the operations role, they can define, well, if you want a data store, it should be this concrete implementation. And it should follow these compliance rules. This is where recipes come in. So a recipe is a template for infrastructure. And well, there are a couple of rules to follow. If you want to create one of these Radius recipes, then you need to make sure that you stick to the right resource type. So a recipe is always of a concrete type. You need to make sure that you return the values that Radius expect to be returned, so they can take that return value and stick it into your application. And this is where connectivity comes from, of course. So your template needs to say, okay, this is my connection string, so your application can know where to connect to. Makes sense, right? And the final thing that you need to do is deploy that template to an OCI registry. For example, Azure Container Registry or something similar. So it can be imported by Bicep later and then used without you having to know the definition of it. And of course, as you can see on the right, in some cases, when the recipe is a container that runs on your local Kubernetes cluster, of course, your recipe will need to have some Kubernetes resources defined, which requires Kubernetes expertise. All right. So if you want to use one of these recipes, please have a look at the file on the right. So on the bottom, you see the application environment. It has a recipes line there. Maybe if I use this, then yeah, it has recipes here. This is the name of the recipe, and this is where to find it. So I made my own ACR and made it publicly accessible. So if you want to run my demos, you can even do that. And then if I have an application that wants to use one of those recipes, I say, well, this is the type, Redis cache in this case, and this is the name. So by that means I can say, please deploy this Redis cache for me. And the application developer doesn't know anything about the implementation details of that Redis cache. Well, like I already mentioned, a recipe needs to have a type, but not every type on the planet is supported by Radius yet. And this is where extenders come in. So, well, this is the thing that comes closest to object as the resource type. So Radius doesn't know about the actual thingy being deployed. You can deploy it, and if you want to return some stuff, that's fine, but Radius won't know what to do with it. And because, for example, OpenTelemetry is not yet supported by Radius, I'm using this extender approach to deploy generic container into my cluster. I will promise to return some stuff, and I need to assume that my application understands what is being returned. So this is, well, vague and necessary while it's still being developed. Right. Again, this will come up in a later demo, so don't worry if you don't fully grasp it yet. All right, so if we look at our roadmap to production, we can cross off another item. We know now that we can deploy recipes to environments, making really nice test environments that use containerized state stores and messaging systems. Next step is to do a little bit of state store and messaging, but then ready for production. And this is where radius connections come in. Like I already mentioned, a recipe needs to return information to the application. And the way the connection is made is by using radius connections. So you have an application that uses a recipe, and then you can add a connection to that deployed recipe instance. Of course, a connection is just an environment variable. So it takes information coming out of the recipe, connection string again, for example, and it puts it into your application, and it's up to you to make sure that the application understands that variable and knows where to find it and knows how to deal with it. It's not magic or voodoo happening here. All right, so let's add a state store to our single front end and then see how that works using radius recipes. That would be script number 2. Go to the right directory, and I'll skip all the stuff from before, and now I will just immediately deploy my app v2. And while this is running, I can quickly compare app v1 and app v2 by putting them side by side. The key differences between app v1 and app v2 is that this environment doesn't have recipes and this one does. So I'm using a Redis cache recipe here. And of course, my application needs to be connected to that Redis cache, and it happens over here. So my application now has a connection. And that's it. And because the Radius team made sure that they understand the environment variable that is now coming in through this connection object, that makes sure that it knows where to find it. So if this now worked, I can go back to my demo. And keep an eye on the gray area here. So, no connections defined. If I refresh, I forgot one thing, sorry. I need to expose that resource. So I need to make a port forward to my cluster. That is now in place. Yes. And now the gray area, no connections defined, has changed into orders. So apparently it has an orders data store, and it knows where to find it because of the environment variables that it received through the connection object. Straightforward. Right, let's kill this and remove. I will first show you the environment. Like the recipe is now part of the environment. You can see it in the bicep, but also here in the JSON. And remove this application. Cool. Yeah. Go back to the slides. Well, it's a good thing that Mr. Dapr is here himself. But so if you want to know more about Dapr, then please visit the guy with the beard on the second row. I will very, very quickly go over Dapr. The absolute bare minimum of the love connection between Radius and Dapr. So, Dapr is a CNCF project. It is short for the Distributed Application Runtime. And the way it works with Radius is that it creates an abstraction between the concrete state store or messaging implementation and the software. So if you have software that wants to use storage, or you have software that wants to use PubSub messaging, in a dev environment, you want it to use containerized resources. In a production environment, you probably want to use PaaS services in the cloud. And Dapr is really good in abstracting the specific details away. So it offers a generic API for state store, for messaging. And you just say, hey Dapr, send a message for me. And the concrete implementation will be targeted by a specific Dapr component. So it knows how to talk to Redis. It knows how to talk to Azure Service Bus. But the software doesn't need to know about that. So then, all of a sudden, I can deploy my application in a test environment or in a production environment without changing a single line of code by merely changing a little bit of configuration. And this is why I added Dapr to my demos as well. So instead of talking to Redis directly from my code, I will start talking to Dapr, and Dapr will decide, okay, I'm configured to talk to either Redis or Azure Service Bus. Really nice. And the way we do this, of course, again, is by deploying a recipe. So Radius has built-in support for many Dapr components. And that means that I can just say, well, I will define a recipe for Dapr state store. And the actual implementation, well, as a product team, you don't really care about it. And as an operations team, you can say, well, for test, it's OK to run a container. For prod, it's OK to run on Azure or AWS or Google. Really nice. Right, let's see this in action. Righto, right directory, and deploy app.bicep. And again, this is a little bit long-running process. So while that is running, I will go to my file and explain it a little bit. Get rid of this stuff. Right. Okay. So I have an application. I have an environment. The environment has registered a recipe. So whenever I want to use the recipe in my application, I need to register it in the environment. And I'm using modules, so I can have multiple files collaborating. So I'm using a front-end file and a back-end file. And if I view the back-end file, for example, then you can see, well, my state store, it is a Dapr state store. I really don't care about the implementation. By selecting a specific recipe that the operations role has put there for me, I don't care what it is. I just want to talk to it from my application. Don't really care about the details of implementation. And then, of course, well, this should look kind of similar. It has a container that uses the state store, of course, and it does so by an extension. Only thing that I need to do now is to make sure my application also gets the Dapr sidecar, and that is what you see happening here. And then by this extensions block here, Radius will know, okay, this when I run this container, it should also get a Dapr sidecar container attached to it. Well, so far so good. Who spots the difference in the CLI command I did before and I'm doing now? 10 bonus points. No? All right, so before I did red run, which did the port forwards immediately, and now I did red deploy, which deployed the applications, but did not do the port forwards. The reason for this is that I want to use my CLI for a bit more. I want to execute CLI commands, and if I do the port forwards, that's a blocking call, so that will block my CLI. So, a nice way to show you two different ways of deploying an application. But I will need my port forwards, so I chose to put them in a batch file and run them in different terminals. So you see that happening now. So all my port forwards are now in different windows, and then I can free up my CLI to show you more stuff. So, let's first go to the application itself. This is the Dapr dashboard. Again, every good open source project has a dashboard, just like Radius, Dapr has one too. And this is the Dapr dashboard of my application. So, I've already selected my backend application, and well, the most important feature here is the logs. So I can easily have a look at what telemetry my application is generating and whether it's happy or not. So let me quickly see. Yeah, okay. It's probably fine. Right, then the next thing is the application itself. So this is the Dapr store. Again, not a demo I wrote myself, but just a simple Dapr store. And this is the first time that the demo gods fail me. Well, I warned you ahead of time. This is stuff that happens. So apparently my Dapr state store failed to boot up properly. And it's giving me a server error below. Well, blame Radius, not Dapr. It happens. Yeah, sorry, can't be helped. All right, so quickly have another look at the Dapr, the Radius dashboard to see a little bit more interesting application. And you can see it has a front end, it has a state store, and it has a back end that uses that state store. Again, it makes it just a little bit simpler to talk about your application, having this graphical interface. Let's kill some port forwards so it won't bother me the next time, and then terminate the application. So let's move on and check our roadmap to production. So we now see that by introducing Dapr to the mix, we can have a single application definition that you can publish in multiple environments, either cloud or locally, without changing a single line of code, and by merely changing a little bit of configuration, which Radius does for you. Well, now it's time to start exposing this application to the public internet, right? So whenever you deploy a web server, you probably want people to access it. And you want to have that done in a secure way, of course. So this is where networking comes into the mix. And Radius has a concept of gateways to do ingress. And a Radius gateway will define routes, as you can see on the right-hand side. So it analyzes the path of an incoming HTTP request. And based on the contents of that path, it will say you go to the front end or you go to the back end. Whatever you configure here will happen. And well, in the example you see on the right, that is the final example coming up later. You can see that every path that has /API in it will be sent to my API project. And you can do that by specifying the application name in there. So the dispatch API name here indicates an application container that I'm running in my system. And everything else will be sent to the front end, which is really nice. And the final bit I wanted to tell you about the gateway is that you can also configure certificates here and do TLS. So you can either do TLS offloading or TLS downstream as well, but at least do TLS here for the incoming traffic. Right, so this is an app I use for a different talk. It's my mission critical talk. If you Google around, then you might even find it. It is somewhat real world application. So this thing exists in the real world as well, and it's very similar to this. So it has a single page web application as a front end that talks to an API. The API talks to a plant, which is somewhere downstream, but it only talks to it through messaging. So there's only messages going back and forth, no direct calls to it. Of course, those APIs will have state stores as well. And whenever I run this locally, I will use MongoDB for state and Redis PubSub for PubSub messaging. And you see a new thingy here, that is Jaeger. And Jaeger is what I use for capturing OpenTelemetry. So all these components that you see, they emit telemetry, like stuff being clicked or sent or stored. Everything will be captured by Dapr, and Dapr emits that the telemetry to a endpoint, a Zipkin endpoint in my situation, and this is the thingy that hosts that endpoint. And it has a little bit of storage as well, so it can also be used to see what's going on in my cluster. So it adds observability to my application. Right, what's important to realize here is that the area I've highlighted on top there, it won't change. So 0 changes for the application definition itself. The stuff that does change is the recipes that I will use. And the recipe determines that I will use a specific type of state store or a specific type of PubSub system. All right, well, single most exciting demo is to deploy this whole application at once. And usually it works, but well, let's see. Full. All right, and again, this is a very long-running operation that I'm about to do, so it gives me time to explain a little bit what's going on. So, deploy app.bicep, and let's have a look at the app.bicep. It is only modules in my app.bicep. So I choose to use different files for different segments of the application. So I separated out shared, and shared, of course, will have that service bus that every system wants to send and receive messages with. And shared will also have that open telemetry container, of course. And this is where, well, my personal opinion comes into play. So if you look at the shared file, then you may feel a little bit like that should be improved. And well, again, in my opinion, this should in fact be improved. So what you see here is that shared resources are always defined twice. So I have a prod environment, I have a test environment. I want to deploy either based on command line parameters, because one is test, one is prod, definitely different. I have not found a way yet to do this properly. So what you end up with is a lot of if-else, 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 like you see here. So if the environment is not production, I will use Jaeger. If the environment is production, I will use Azure Monitor. If the environment is not production, I will use Redis. Otherwise, I will use Azure Service Bus. And finally, oh, that's it, sorry, that was the final. And again, for the application itself, I have two different application definitions and two different environment definitions. So the actual only thing I want is to have two environment definitions, but I don't want to have them on the same workspace. Again, if this is totally confusing, well, then you're in the same street as I am. This is just, well, it's pre-release software, so this is, it's bothering me. Okay, this is the test environment definition. And again, for the time, this is where you define your recipes. And for local recipes, I explicitly name them. Like, this is my local PubSub recipe, this is my local state store. You can also use default here. I don't think it's very descriptive. So I chose to use local names for local recipes. And then if you look at the production environment, I chose to use cloud as a prefix. So a cloud state store and OTLP collector, which will forward stuff to Azure Monitor. The cool thing is, even though this is my production environment, I'm still free to use containers for state stores that don't really need to run as PaaS. So it's not either or. You can combine cloud resources with local resources just fine. Right. Okay. Let's see what a recipe actually looks like, because I've been talking about them quite a while, but now you know that there are cloud resources and local resources. Let's say I will use PubSub. For PubSub messaging on my local test environment, I'm using Redis. If I want to use Redis on Kubernetes, I need to make sure I have a pod, which is created by deployment. I need to expose it using a service. These are all Kubernetes concepts. So these are what you see here. So I have a Kubernetes service. I have a Kubernetes deployment. The Kubernetes deployment deploys Redis. And then, of course, I need a Dapr component that says, I am a PubSub component. You don't need to know any details, but here is the connection information that your application needs to know. If you compare that with a service bus recipe, parameters are the same, output is also the same, no Kubernetes resources here. This is just an old school service bus template. So this bicep is exactly the same bicep as you would use to deploy Azure Service Bus in any other situation. So it's not production ready because I'm using authorization and access tokens. Managed identity is still a bridge too far, but it does give you a nice impression of what this will be like in the future. Right, okay, so forget this one, that shouldn't be here, but the only thing that happens is the creation of an Azure resource and a Dapr component specifying, hey, this Dapr component has this connection string. Application doesn't know, doesn't care. It just needs to connect to that Dapr component. Really nice. I think I talked long enough. Okay, this happens. That's another issue. But based on this issue, I am just going to try it again. Ignore that error. The downside here is that we have to wait a little bit. Maybe we can do your question while this deploys. Is that okay? Yeah? With Aspire, .NET Aspire. Yeah. Great question. I will paraphrase it a little bit for the people at home. So what is the relationship between .NET Aspire and Radius? Right now, these are two competing teams. So they are building a product which has a little bit of overlap. We talked to both teams and we said, what's going on? They seem to be in competition more than in collaboration. Again, that's my opinion, that's not a fact. This is being recorded, so I need to be careful a little bit. So, in my mind, .NET Aspire should really be about the F5 debugging experience and then stop. And then once you are ready to go into an integration-like scenario, this is where Radius can really help. So I think they should be complementary. But now you see .NET Aspire moving all the way to AZD and manifest and template generation. And this is really the part that overlaps with Radius. So right now, there's zero interop between them. They are, well, they say that they are in contact with each other, but I don't see anything pointing into collaboration. Again, all personal opinion here, not fact. Make sense? Cool. And that was exactly long enough for this. Cool. And now it works, and that is, well, welcome to Radius. Don't need to become cynical here. Now it's pre-release software, so it's really okay. So, all right, so I have made my port forward to my application, and that means that I can talk to localhost to see what's going on. So my production-ready system, of course, has health endpoints. So what I can do is use curl to call one of those health endpoints. We'll use the port forward to talk to my application. And, well, this time it did work, so it's reporting healthy, which is really nice. And that means that I can also show you the GUI of my single-page web application. And, well, something to notice here is that it has a TLS warning, and that is because I'm using a self-signed certificate here. Again, this is my test environment, so I don't mind. It's perfectly fine with me. You could also use a .NET developer certificate and trust that ahead of time. So that is just my lack of well, good programming here. Cool. Well, you don't really need to know anything about this application except for that if it works, a blue message box pops up here. And I can test it by doing stuff like this to it. And then if it pops up, then it means that stuff succeeded. And, well, this is now the application running fully containerized. I believe there's more coming here. Yeah. This is my Jaeger dashboard. Again, this is my OpenTelemetry collector. It has an endpoint to which the application will send its telemetry. So I can now start examining that telemetry. For example, I need to zoom out a little bit to know the right one. And then find traces that have something to do with PubSub messaging. Right, and by clicking on it, well, there's no need to go into details, but what you can see is that all the messaging that happened between the two APIs, so the dispatch API sending messages to the plant API doing some processing, state store stuff, and then once it was done processing stuff, it sent a message back, which did a signaler call back to my application, saying that everything was processed, which triggered the blue message box. So that was all happening within the second. In real life, that would take hours, but well, we don't have that much time, of course. But all that telemetry that you see here, it was all put in place by simply using .NET with Dapr and an open telemetry collector. Zero code for all this telemetry gathering and displaying. Kind of impressive. Cool. Right, let's have a look at the application graph before we terminate. Again, details don't really matter here, but what you can see is that even though my application is now quite complicated, I can still discuss my application with different team roles, like operations roles and developer roles, and we can just say, well, we need to do a little bit of fixes here, and we can see relations between these. Well, I'm not sure if you can see it all the way in the back, but there are dotted lines here and here, indicating which system talks to which other system. And if you see lines popping up here that you didn't expect, then you know, well, something's wrong. Right, kill the port forwards, because we have one more demo to do later. Right, back to the shopping list or the roadmap to production. The final thing we need to do now is to define a production environment. So we take the same exact application definition, we replace a few recipes so that instead of containers we now start deploying PaaS resources. And of course, we target a Kubernetes cluster running in the cloud instead of a Docker desktop cluster running on my laptop. Right, if you look at them side by side, again, don't worry about the details. The only thing that I will change is the recipes. The application definition remains the exact same. Zero code changes, zero bicep changes. Only thing that will happen is different recipes resulting in different resources. And now, the most exciting demo, which fails most often. Demo 2. Right. All right, let's go back to my workspaces. So I have a local workspace, which I have been using so far, but I also have a cloud workspace, which targets a production cluster, which is an AKS cluster running in North Europe somewhere. So I need to switch to that cloud environment first. I need to make sure that my production environment is there by creating a resource group I name prod. You can use your own name if you want. And then I need to use the red deploy command again. This is my app bicep file. The environment name is now not test, but prod. And the other parameters haven't changed. Right. Okay. That could take a little bit of time. Let's have a quick look at the shared bicep. So you know that I'm, the plant bicep. So you know I'm not fooling you. So it's the same file I'm using over and over again. And the way I target which recipe to use is by using a variable here. So in my shared file, I know the difference between the production environment and the test environment. I return parameters from that shared file, so I can use them over here. So all that if-else stuff only applies to my shared resources, and my not shared resources, like the plant API, the dispatch API, and the web frontend, that's just a single clean file relying on if-else's done in the shared file. Make sense? Right, well, the rest of the file isn't too exciting. I think I'll just switch back here. I was kind of hoping that it may have been completed already. It looks good. Maybe a quick question while this is running. Yeah.
So how would you say this stacks up and compares with Terraform?
Yeah, good question. Terraform can be used to define recipes. So instead of using Bicep, you can use Terraform. So if you are a Terraform company, there's really no need to say goodbye to it. I can imagine that someday the application definition itself could also be described with Terraform because it's just text. So in my mind, it should be fine. I'm a great fan of Terraform myself. I would rather use Terraform everywhere. So maybe some point like you can convert Bicep to ARM. Maybe they will have a converter that converts Terraform to Bicep or vice versa. This is all me speculating, of course.
But you do see a possibility for interplay between
Definitely, yeah. They see it themselves. Like I mentioned, if you define a recipe, you can already use Terraform in a Terraform module, which you put in some registry somewhere. So it's, I suppose it's on the radar. Yeah, long enough. Okay, now instead of going to localhost and talking to localhost with port forwards, I'm now in production, right? So I don't have port forwards anymore. I can just immediately go to demo.lookd.com. This will work on your phone as well. You can't log in. First, let's check the health endpoint. So that's the curl call to my health endpoint. It reports healthy. That means that I'm probably going to be happy. Let's go to the actual application. Well, you see now that I have a proper TLS certificate, which is valid today for that specific domain. So that's really nice. I'm now signing in and going to the dispatch page. And again, if everything works well, then you should see the blue square popping up here. And I will look a little bit silly doing this, but it has a reason. So I'll not just click it once, but a bunch of times. That has to do with the next steps. You see the message box popping up. So there's a really good chance that stuff is actually going through cloud resources now. But, well, you don't have to take my words for it. Let's see what's going on in the Azure portal. So first, service bus. So instead of Redis pops up on my cluster, I'm now using a PaaS service called Azure Service Bus, which has Dapr to abstract the details away. So I'm just sending messages from my application. Dapr is now configured to use Azure Service Bus. And, well, stuff will end up here. And if I talk long enough, then stuff should start showing here. This is like Microsoft needing to do a little bit of work. I can't speed it up. We may need to circle back. That's too bad. I'll circle back later. So same deal for my state store. So I was using MongoDB locally, and now using Azure Cosmos DB, which is document storage in Azure. Okay. I've not been talking long enough for this to show up, but what I can do is go to the Data Explorer and show you that, well, apparently it has a plant collection and a plant state, plant account and plant state collection. And, well, the fact that this is here, at base 64, that is, well, if I were to decode it, it would be 63. That's the total gas in store here. So that's pretty cool. Maybe if I close it up right now, it starts showing traffic as well. No, it's too bad. Yeah, well, Service Bus has woken up. I've clicked the button a bunch of times, so you can see that the messages have been processed by Azure Service Bus instead of my Redis pops up. So Not just making smoke and mirrors here, it's actually running in production. Right, final step would be to have a little look at the telemetry. I was using Jaeger on my local environment, and now I'm using Azure Application Insights in my production environment. And if all goes well, yeah. So this shows an application map and all the traffic flowing between it. All the clicks that I did have been captured and are, well, can be inside here. And that is actually the end of my demo, so really nice. Quickly wrap up. So we got that all covered. In the future, not today, Radius can help you. Please don't use it in production today. Start messing around with it in your innovation environment. Get a feeling about how it works. The whole theory of platform engineering, it will be here within a couple of months or years. So it is a fact of life that you're going to have to deal with this. And with that, if you want to have the sources, take a picture of this one. If you want to get in contact, also well, feel free to connect on LinkedIn. And of course, if you have any questions, come see me afterwards. That's it.